Hi, an important topic from network analysis, a source transformation. It may be from voltage to current source or a current to vice versa. Topic may be small but a very important and useful transformation technique while we deal with various circuits in network analysis. It may be a practical voltage source. I repeat, a practical voltage source. Why? Because the ideal voltage source, there is some difference. Alright, so practical voltage source, it will be like this one, with a positive and a negative over here. Alright, and practical voltage sourse, we have to represent that the voltage source with the internal resistance of the source. It's we say that RSE in series. Alright, the internal resistance should be represented with this one, and this will be the place, like this is the load resistance RL. Alright, so load resistance RL. Now some current will be flowing I, and this current is equal to the load current IL. Why am I talking? Because that transformation technique is somewhat interconnected. There is a relationship between, we have to speak that transformation. The transformation should be done with respect to the load current. Alright, now watch carefully. This is the arrangement. Alright, right? This current and the same current is load current, that current flowing through the load. So how can that be written? Like IL can be written as if I say it's a V, voltage source V. Alright, so according to Ohm's law, something like that, it will be V upon total resistance, isn't it? RSE, which is the internal resistance of the voltage source, plus load resistance, the complete resistance of the circuit. Now this will be the expression for the load current through the load. Alright, now this transformation technique says, in the place of voltage source, we can plug in, this can be substituted with a current source. There is something provided something. Alright, we can remove this one. This could be substituted with the current source, provided that the same load current, the same amount of current flows through the load. Alright, we can substitute anything. We can substitute with the current source, provided that the same amount of current should be flowing through the load. So that we need to come to a conclusion with the help of some modifications and all, some important derivation. Alright, so this is the one. And what did I say? The same here, the load resistance as it is. Alright, that load resistance RL as it is, and that same amount of load current should be flowing. Then only, like what value of current source should be plugged in over here is the question. Alright, so we can have that current source. Now we need to express this in terms of this one. Why? Because if this is given and if these values are known, then we can make use of having known these values, we cannot go for whatever value of current source, isn't it? There is some interconnection. Alright, and current source with a shunt resistance RSH. Alright, now this is the total current I. This is the total current I flowing, and after this node it will be ISH, and this will be the load current IL. Alright, and what is that? What do we have here? It's now soon after this node there is a current division. So making use of current division rule, writing the expression for load current IL according to current division rule. IL will be written as the total current I into the opposite resistance, right? It's RSH upon the total resistance. It's RSH plus RL. Alright, this is the amount of load current that should be flowing if this voltage source is represented with the current source. Now guys, even this is IL from this one and this is IL, so these two are equal with respect to these two networks. Alright, so what it is, it's IL which is equal to this one, even this is IL which is equal to that. So V by RSE plus RL will be equal to I into RSH upon RSH plus RL. So guys, from here itself we can come to a conclusion. What value the current source should be replaced in terms of this one? What should be the value of RSH if we know these values? All right. So from here, this equal to this. All right, and this equal to this. So what it says, V equal to I into RSH from the numerators. All right, and from the denominators, what do we have? RSE plus RL is equal to RSH plus RL. So guys, what do we have from this one? It's this one. So RSE will be equal to RSH. For supposing we have this one, we are dealing with this one, and we need to convert this voltage source into current source. This has the RSH, which has to be plugged in over here, should be equal to the RSE value. And what value of current source that should be? That is given over here. We come back to this expression. I is given as V upon RSE. Alright, so this is the amount of the value of current source that has to be plugged over here. And what should be the value of RSH? The shunt resistance should be equal to the series resistance of this one. Alright, this is the proof for source transformation technique. Hope you understood. Thanks for watching.